Maupay nga adlaw sa iyong atanan. Welcome to Engineering e-Learning Channel. For today's topic, Simplified Integral Calculus. Under Technique of Integration, Integration by Substitution. Part 2, Trigonometric Substitution. The following trigonometric substitution are especially helpful for a specific form of integrand. As you can see in your screen, when the integrand involves for a difference of 2 square, you can try to use u is equal to a sine theta. Or for your b, sum of 2 square, a squared plus u squared, you can try to use u is equal to a tangent theta. Or for your letter C, the difference of 2 square, u squared minus a squared, you can try to use u is equal to a secant a. In this case, a is a constant greater than 0. So the suggested substitution in your screen and some technique discussed in transformation using trigonometric formulas, a complicated integrand may be rewritten into an easier function. So you need to manipulate your function aligned to this useful trigonometric substitution. Moving on to your first example. Okay, for your first example, example number 26, evaluate the integral of square root of 4 minus x squared all over x squared dx. So your problem can be found in your workbook on page 100. Okay, so what is your first step in dealing this kind of function? Of course, you need to observe, examine your function. So for your integral square root of 4 minus x squared minus all over x squared dx. Okay, so we need to examine the function. In our previous topic, algebraic substitution, we always choose part of the function which are difficult to integrate. And now, for our trigonometric substitution, we'll use the portion of our function that is difficult to integrate. We choose those functions with involving radicals or complex form. So we use this square root of 4 minus x squared. Now, with some useful trigonometric substitution, we can assume or we can use this function using our trigonometric substitution. Okay, we rewrite our function first. Square root of 4, that would be 2 squared minus x squared all over x squared dx. So we have a difference of 2 square. So for difference of 2 square, we can use a squared u squared, which is equal to u a sine theta. If we align our difference of 2 square, so this is our 2 squared minus x squared, which is equal to your x 2 sine theta. So we can assume this as your equation 1. In our previous topic, we always determine the value. In algebraic substitution, we assume certain variable, for example x. If we already know the value of that variable x, we solve that variable with respect to x. So here, we solve theta with respect to x, or in the other way. So we need to determine the first derivative of x. So that is your derivative of x. If we're going to get the derivative of 2 sine theta, that would be 2 cosine theta d theta. Okay. So our next step is to rewrite our function according to our determined new variable based from trigonometric substitution using the difference of 2 square. Okay, so we rewrite our function. Integral of square root. So 4, still 4, minus x. We already have a value for our x. That is quantity 2 sine theta squared. Okay, so all over our x, we have a value for our x. That is 2 sine theta squared. And our dx, we replace our dx with our determined value. In our previous topic, we call this the correction factor. The process is the same, but in trigonometric substitution, we introduce this trigonometric substitution equivalent to a certain difference or sum of 2 square. Okay, so we have dx, that is 2 cosine theta d theta. Okay, so we simplify our function based to our new variable involved. Start, we need to distribute the square inside to the quantity. Integral of square root of 4. If we distribute the square, become 4 sine squared theta all over the same 4 sine squared theta, and the dx, that is your 2 cosine theta d theta. So what is our next step? We use property number 2. So property number 2, we carry out real number constant going to our integrand. Okay, let's do it. And we need to recall also some identities. We recall the value of our 1 sine squared theta is also equal to cosine squared theta. So some of our identities. So we use that identity here. But before you can use this identity, you need to simplify or factor out 4 in this quantity. Okay, so we carry out 2 outside the integrand. So we factor out 4, that would be 1 minus sine squared theta all over 4 sine squared theta. And for the remaining, there would be only cosine theta d theta, because we already carry out the real number constant to the other side. Okay, so we need to use your trigonometric identities. Okay, if you use that, that would be 2 integral square root of 4. So we replace our 1 minus sine squared with this identity. So that would be equal to cosine squared theta all over 4 sine squared theta. Then our remaining cosine theta d theta. Okay, so we furtherly simplify. If we're going to distribute the radical inside, okay, so we need to eliminate this radical. So that is square root of 2, square root of 4, square root of cosine squared theta all over 4 sine squared theta cosine theta d theta. So what will happen next? So we cancel out some properties. So this will become 2. We cancel out square root. Or this will become 2. Okay, so the remaining square root of 2, 2 cosine theta. So we can multiply it to our existing cosine theta d theta all over 4 sine squared theta. Okay, so what will happen next? So we carry out real number constant. Do we need to carry out? Not yet. So we multiply 2 cosine, that would be cosine squared theta all over 4 sine squared theta d theta. So we need to use again an identity of cosine theta over sine theta is equal to cotangent theta. We can use this and rewrite our existing function. Okay, using our relation, that is 2 integral of, we have a common of fraction 2 over 4. They have the same power, so we can use cotangent because they have the same power. So cotangent, what is the common power? 2 theta. Okay, of course your d theta. And here we use another identity, that is your cotangent squared theta is equal to cosecant squared theta minus 1. So we use this identity again. Okay, we rewrite and carry out that real number constant. Oh, we need to reduce. So we cancel here. It would be 2. So the remaining would be 2. 2 integral of our identity. Then our cotangent squared theta d theta. We simplify this with this 1/2, so the remaining is 1/2. Okay, so it's already cancelled out. So the remaining would be cotangent squared theta d theta. Here we can use this identity. If we're going to use that, that's integral of cosecant squared theta minus 1 d theta. And we can use our property number 1. We distribute the integrand and our d theta. Integral of cosecant squared theta d theta minus integral of your d theta. So if you're going to integrate cosecant squared to theta, that is negative cotangent theta minus integral of d theta, that is theta plus c. So you have an answer of negative cotangent theta minus theta plus c. But we need to determine the value of our theta. Did we determine here? Not yet. But we're going to use our equation 1 to determine our theta. Okay? So based from our equation 1, from 1, we have x sine from our equation 1, we have x is equal to 2 sine theta. If we're going to manipulate this, that is x is equal to 2 sine theta. So over 2, cancel your sine theta is equal to x over 2. Or we can say your theta is equal to arc sine of x over 2. Okay, if you recall our formula in trigonometric, you can recall that if we're going to draw a right triangle, so this is our theta. So sine, so this is our opposite, this is our hypotenuse and adjacent. Sine is for so, that is opposite over the hypotenuse. So you have opposite x and hypotenuse. To determine theta for cotangent, cotangent is sokatowakaw. So cow. So that is cow is equal to cotangent theta is equal to cow adjacent over opposite. So we already have an opposite, but we need to determine our adjacent. So to determine our adjacent, we only use the Pythagorean theorem to determine. So if this is a hypotenuse adjacent, unknown adjacent with existing opposite and hypotenuse, we can say that if we derive from Pythagorean theorem, adjacent is equal to the square root of 4 minus x squared. Adjacent is only from the Pythagorean theorem. That's why we derive 4 minus x squared, the square root of 4 minus x squared. So now we rewrite our cotangent. So adjacent, we have square root of 4 minus x squared all over the opposite x. So we have a value of theta for cotangent. So therefore our theta for cotangent is cotangent negative 1 is square root of 4x squared all over x. So we just substitute the value of our theta to our existing answer. So we rewrite negative cotangent. So we substitute theta from our cotangent. That is cotangent negative 1 square root of 4 minus x squared all over x and minus theta. What theta you're going to use? Of course, you're going to use theta from sine since we derived theta from equation 1. Okay? So minus sine arc sine x over 2. Then r plus c. So we cancel out some common factor. So negative cotangent. So it will be cotangent and cotangent. So reciprocal. So cancel. So the remaining negative. So we have negative square root of 4 minus x squared all over 2 rx minus, that is your arc sine or sine negative 1 x over 2 plus c. So that is your final answer. So this is your final answer for our example number 26. Okay, so for question, comment down below, or you can send me your personal message to our Moodle account. Okay, moving on to our next example, we have for our next example, example number 27 can be found in your workbook on page 101. So example 27, evaluate the integral of z cubed dz all over quantity 16 plus 9z squared raised to the power of 5 halves. Again, we need to choose part of our function which are difficult to handle. So we choose the denominator and use our trigonometric substitution. But before you can do your trigonometric substitution, you need to simplify in a form of power your denominator. Okay? So equal integral of say cube dz all over 16 plus 9z squared. So we rewrite our denominator aligned to our trigonometric substitution. Okay, so z cube dz all over. So this is raised to 5 halves. Okay, quantity. So square of 16, that is 4 squared. So that is 16 plus your quantity, square root of 9, that is 3 z squared. So if you distribute the power of 2, this will become 9z squared. So this same with our denominator. And of course, raised to power of 5 halves. So we have the sum of 2 square. So we can use our trigonometric substitution. A squared plus u squared is equal to u a tangent theta. So we'll make our 4 our a plus our u as short 3z squared. Therefore, 3z is equal to 4 tangent theta. But we need to determine the z with respect to our theta. Okay, so if we manipulate this, you can say that this is our, if we manipulate, we over with 3. So we have z is equal to 4/3 tangent theta. So cancel 3 all over 4/3. Okay, so we can say this is our equation 1. And of course, we need to get the first derivative of your z. So that is dz is equal, so derivative of 4/3 tangent theta, that is 4/3 secant squared theta d theta. Okay, so we substitute z and dz to our existing original function. Okay, equal, so we substitute z cube. So for our z, that is 4/3 tangent theta raised to 3. How about for our dz? So we substitute our dz here. So we have 4/3 secant squared theta d theta all over 16 plus 9 your z, 4/3 tangent theta squared raised to 5 halves. So that is raised to 5 halves. Okay, so let's continue. Let's apply it the power of each quantity. Okay, so 4/3 raised to cube. So 4/3 raised to cube, that is integral. So there is an integral sign there. Quantity, so that is 64 over 27 tangent cube theta. So we copy the neighbor, 4/3 secant squared theta d theta. And for denominator, so we need to square 4/3 tangent theta first. Okay, so 16 plus 9 quantity is square of 4/3, that is 16 over 9 tangent squared theta, of course raised to 5 halves. Is there anything we can cancel out? Yes, we have common of 9. We can cancel out 9. Okay, then we can multiply at the numerator 4 third times 64/27. Then tangent and secant. Okay, integral 64/27 times 4 third. That is 256/81. So tapi tangent, tangent cube theta, and secant squared theta and d theta. How about sa denominator? It will become 16, the remaining one, 16 plus 16 tangent squared theta raised to 5 halves. Okay, so we need to factor out 16 plus 16 tangent squared theta. We carry out 16, so we have trigonometric identities here that we can use. At the numerator side, we apply property number 2. We carry out real number constant. So we carry out real number constant and we factor 16 plus 16 tangent squared. Okay, so 256/81 integral of quantity, the remaining tangent cube theta, secant squared theta, d theta. At the denominator, we factor out 16. So we have 1 plus tangent squared theta raised to, of course, including 16, 5 halves. Do we have a identity we can use here? Yes, we have. For tangent 1 plus tangent squared theta, we can use 1 plus tangent squared theta. We can use secant squared theta. So we can use this identity there. Okay, let's apply that identity. 256/81 integral of tangent cube secant squared d theta. Then 16 quantity, we replace 1 plus tangent squared theta with our identity secant squared theta raised to 5 halves. Okay, what our next move? We need to apply our root to our 16 secant. Okay, if we apply our square root, we cancel out. If we apply our square root here, we cancel out 2 and reduce 16 to what? Of course, the square root of 16, that is 4. Okay, we rewrite. That is 256/81 integral of tangent cube theta secant squared theta d theta all over. So this is only 4 secant theta. Of course, you still have a raised to 5 power. Then apply the fifth root again. If we apply our fifth root, would be the fifth root of 4, or the power of 4 secant 5. So that is 25681 integral of tangent cube theta secant squared theta d theta. So 4 raised to 5, that is 1024 secant raised to 5 theta. We further simplify. So we carry out 1024 outside the integrand. So that is 25681 times our 1000, 1 over 1024, and copy the remaining. And we need to cancel out some common, of course. So we have secant raised to 5. So cancel out secant squared theta. So secant to the 5th, well, remaining will be 3. Okay. So the remaining is tangent cube theta d theta all over secant. So 5 minus 2, that is cube d theta. Okay. So we multiply 256 all over 81 times 1024, that is 1 over 324 integral of tangent cube theta all over secant cube theta d theta. Here we can use identity. Can use this relation tangent theta over secant theta is equal to sine theta. So we use this one. Okay, equal to 1 over 324 integral. So we replace tangent over secant. So that is sine. Sine, they have a common power of cube, copy cube, theta d theta. So can we integrate this based on our trigonometric substitution before? We need to have a power of 1 for our sine. So we manipulate our power. We break this 3 to 1 over 324 integral of sine theta and sine squared theta. So that is to the power of 3. So we can easily use another identity for our sine squared d theta. So for sine squared d theta, here we can use sine squared theta equal to 1 minus cosine theta. So we can use this identity. Okay, replacing our sine squared theta with this identity. (324) integral of sine theta. Quantity, we replace sine squared theta with our 1 cosine theta d theta. Okay, simplifying further, we distribute sine to inside the quantity. It will become 24 sine theta minus sine theta cosine theta quantity d theta. Okay, so we'll rearrange sine cosine. Sine squared theta is equal to 1 cosine squared theta. So this is 1 minus cosine squared theta. This is also cosine squared theta. Okay, do we have identities again that we can use? We distribute our real number constant inside the quantity, so we have difference of two function. Okay, if we do that, so that is 324 integral of sine theta d theta 1 over 324 integral of, this is minus minus sine squared cosine squared theta d theta. So we solve. We have a two function to solve. Okay, let's move to our next page to continue our discussion. So we have two function to solve. 1 over 324 integral of sine theta d theta minus 1 over 324 integral of sine theta cosine squared theta d theta. Here, we can integrate right away. If you're going to integrate this one, right, our first term, that is 1 over 329, the integral of sine theta, that is negative cosine theta. Okay, so we can say that in our first term, that is equal to negative 1 over 324 cosine theta. So we are okay in our first term. Okay, moving on to your second term. Do we have an identity that we can use here? Or maybe we can determine the correction factor of our function. So we can apply property number 3. So correction factor, you will use our u as our cosine theta. So the first derivative of your cosine, that is what? Negative sine theta. So finally, your d theta is equal to the reciprocal of your first derivative, du. So that is equal to du 1 over negative sine theta d theta. So we apply our correction factor here. So that is d theta. Okay? So minus 1 over 324 integral of sine theta. We replace our cosine with our u. That is u, copy the power, and apply our correction factor 1 over negative sine theta d theta. Sorry, this is du. Since this is, we have our d theta. This is our d theta. This is our du. So this is our du. Okay? So we cancel out common sine theta, sine theta. So we have a remaining of negative. So we carry out. So negative times negative, that is positive. Positive, so the remaining is 1 over 324, that is positive, okay? This is positive, negative times negative, so this is positive integral of, so the remaining u squared du. So we can apply our power formula here. So if we apply our power formula, remaining is 324 quantity u2 plus 1 over 2 plus 1 plus c, both constant of the first term and the second term. So finally, that is 1 over 324 quantity u cube over 3. So 1/3 times 324 That is 1 over 972. So what is the value of our u? We recall our cosine, power cube, theta. So we copy our answer in the first term. So negative 1 over 324 cosine theta. So this is your partial answer. Partial y, we still need to determine the value of our theta, right? Okay, so in our previous slide, from our equation 1, we have a value of our z. A value of our z is equal to 4/3 tangent theta. So from here, we evaluate. So if we evaluate this one over 4/3 over 4/3, so our tangent theta is equal to, so 3z over 4. Okay, so our arc theta is tangent -1 or arc tangent 3z over 4. That is for theta. But we need our cosine theta. But we will use this relationship. So if we're going to draw a right triangle, so this is theta. So tangent TOA. So that is TOA, right? TOA. So opposite over the adjacent. So our opposite is 3z. Our adjacent is 4. So we need to determine our hypotenuse. This is opposite, this is adjacent. So we just use our formula in Pythagorean theorem. So that is the power squared of 4, that is 16. Square of 3z, that is plus 9z squared. Of course, the square or the power of the other side, that is square root of 16 plus 9z squared. So that is your hypotenuse. We need cosine. So what is our cosine? That is cosine, that is ka. So ka. So ka. Ka. So that is adjacent over the hypotenuse. Therefore, our cosine theta is adjacent 4 over the hypotenuse each, which is equal to square root of 16 plus 9z squared. So we already have our cosine. Of course, we need to get the arc cosine. So your theta for your sine is cosine -1 4 over square root of 16 plus 9z squared. So we substitute our cosine here. Okay, we rewrite this one here. Maybe we can use some space. Okay, so -1 over 324 cosine. So substitute our theta. Cosine -1, it's a reciprocal of your cosine. You can rewrite this cosine -1, which is equal also to 1 over cosine. So since it's just a reciprocal, or they read it as arc cosine, arc cos, but they are all the same. Okay, so 1 over, so your theta, so that is cosine, or we can use this one, 1 over cosine, then 4 over square root of 16 9z squared. So we close, then we deal for our second term. Second term is plus 1 over 972 cosine cube endure theta. That is 4 all over square root of 16 minus 9z squared. Okay, so we need to cancel some common. So we cancel out cosine, cosine. The remaining is this one. About here, we distribute the power inside the quantity. Okay? So our final answer, so 1 over 324 times 4. So that is 324 over 4, this one, and distribute 1 again, that is 1 all over 81. Of course, our square root of 16 minus 9z squared. So plus the other side. So 972 over 4. Okay. That is your 16 over 243. Your 1 over square root of, you apply your power, okay? Your cube root will become your cube root. We still have cosine negative 1 here to cancel out this one, okay? So we apply the power cube to our root, so that will become cube root 16 minus 9z squared. So we furtherly multiply this one. So for your final answer, that would be 1 over 81 square root of 16 minus 9z squared plus 16 over 243. We distribute it here. So that would be 16 all over 243 cube root of square root of 16 minus 9z squared plus c. So this is your final answer for your example number 27. Okay? So for question, you can comment down below, or you can send your message to our GC, or you can personally message me in your Moodle account. So moving on to our next example. Okay, for the correction for our final answer for example number 27, I've noticed something. So our final answer is supposed to be positive. So 16 plus 9z squared. So we substitute the value of your theta. So this should be cosine positive. Square root of 16 plus 9z. Also 16 plus 9z. So 16 plus 9z, 16 plus 9z, 16 plus 9z, 16 plus 9z. So that is for correction for our example number 27. Okay, moving on to our next example. Okay, for your next example, example number 28 can be found in your workbook on page 103. So example number 28, evaluate the integral of square root of y dy all over square root of 4 minus y. For solution, again, before we apply our trigonometric substitution, we need to select part of our function that are difficult to integrate. So in this case, we choose square root of 4 minus y. Okay? So we can assume that this 4 square root 4 minus y as a difference of 2 square. Okay, so equal to integral of square root of y dy is square root of 4 minus y. So we can rewrite it. So integral of square root of y dy all over. So we can rewrite this to difference of 2 square. So we can say that that is 4 or 2 squared if we apply our radical. So and square root of y. So difference of 2 square. So we assume that it is a difference of 2 square. So we can use trigonometric substitution. So if we can recall the difference of 2 square, a squared minus u squared can be rewritten as your u equal to sine theta. Okay, so we align. So for our a, that is your 2 squared. For your u squared, that is your square root of y. Therefore, you can write it as your square root of y equal to 2. Your a here, your 2 sine theta. Okay, so we need to find the value of our y. Just remove the radical. So we can write this as y. If you remove the radical, it becomes power of 2. That is 2 squared, that is 4 sine squared theta. Okay. So we need to get the first derivative of our y. So that is your dy. So if you get the first derivative of your y, that is 4 sine 2 theta. As we can recall, sine 2 theta can be written as your 2 sine theta cosine theta. Okay, we replace our sine 2 theta with this. Okay, finally, your dy is 4 times 2 sine theta cosine theta d theta. So finally, your dy is 8 sine theta cosine theta d theta. So you have your value of your y and your value of your dy. So now we substitute it back to our original function. Square root of y. What is the value of your square root of y? That is 2 sine theta. So 2 sine theta. Your dy, you have your dy. So this quantity 8 sine theta cosine theta d theta all over square root of 4 minus, what is your y? 4 sine squared theta. 4 sine squared theta. Okay, so what is our next step? We combine these two at the numerator and we factor out 4 at your denominator. Okay, it's integral. So if we multiply 2 times 8, that is 16. We carry out right away. So 16. 2 times 8, 16. So we carry out outside the integrand since it's a real number constant. So the remaining at the numerator is your sine squared theta and your cosine theta d theta. At your denominator, you can factor out 4. Square root of 4 quantity 1 minus sine, that is squared theta. Can we use some identity here? Yes, we can. We have an identity for 1 minus sine squared theta. As you can recall, your cosine squared theta can be rewritten as 1 minus sine squared theta. So we use this identity. Substitute here it back. So 16 integral of sine squared theta cosine theta d theta all over square root of 4. The remaining, replace 1 minus sine theta with cosine squared theta. That is cosine squared theta. Okay, so next, we apply the radical at the denominator. So if we apply a radical to our denominator, that will become square root of sine squared theta cosine theta d theta. So we apply our square root or our radical. So 4 square root of 4, that is 2. Square root of cosine squared theta, that is makakancel out your squared, your cosine theta. Okay, so we cancel out some common. If we cancel out 2 to 16, that is 16 over 2, it will become 8. And for our numerator, we also have common here. So we can cancel out cosine theta and cosine theta. So the remaining is 8 integral of sine squared theta d theta all over. So we don't have a denominator anymore. We already canceled it out. Okay, so 8. So what is our next step? We use some identities again for our sine squared. If we recall, sine squared theta is equal to 1 minus cosine squared theta. Okay, so we replace our sine squared theta with our identity. So that is 8 integral. So sine squared is equal to 1 minus cosine squared theta. Of course, our d theta, don't forget. So we apply our property number 1. We distribute the integrand inside, including the real number constant. So if we do so, that is 8 integral of 1 d theta minus 8 integral of cosine squared theta d theta. Again, we have an identity for our cosine squared. We can use cosine squared theta is equal to 1/2 quantity 1 plus cosine 2 theta. So we can use this identity in our second term. Okay? Okay, so we rewrite. So if we integrate 8, integral of d theta, that is 8 theta already. So minus 8 integral. So we replace cosine squared with 1/2 quantity 1 plus cosine 2 theta, of course, our d theta. Okay. So we cancel out 8 with 1/2. So it will become 4. This one. Okay, moving on. That is 8 theta. So we can distribute, as you can see, we can distribute our 4 inside the quantity 1 minus cosine theta. Okay, so we distribute it right away. So that is 4 integral of d theta, applying our property number 1 here in our second term. Our second term will be break into 2 term again. So that is 4 theta plus 4 integral of cosine 2 theta d theta. Okay. Do we still have a identity for cosine 2 theta? If we integrate cosine 2 theta, so we write our existing first. So 8 theta minus, we have 4, or this is 4 theta. So they are common, it's okay. Plus 4. If we integrate our cosine theta, our cosine 2 theta, that would be equal to 1/2 sine 2 theta plus c. So we cancel out some common again. So here, 8 minus 4 theta, this will become 4 theta. So here we have common 1/4 over 2, they will become 2 sine 2 theta. Okay, we rewrite our answer. That is 4 theta plus 2 sine 2 theta plus c. Okay, let's recheck our answer. 8 minus, so we distribute it minus, so minus, this should be a minus here. Okay, so for this, it should be a minus also. Okay, here also this should be a minus. So 4 theta minus 2 sine theta 2 theta plus c. We still have identity here to use. As you can recall, sine 2 theta is equal to 2 sine cosine theta. Okay, we replace it. 4 theta minus 2 quantity. We replace it with sine cosine 2 theta. Will become 2 sine theta cosine theta plus c. So your answer is 4 theta, so times 2, that is 4 sine theta cosine theta plus c. Okay, we need to determine our theta. Okay, let's move to next slide so we can determine our theta. So, okay, what is our final answer? Our final answer a while ago was 4 theta minus 4 sine theta cosine theta plus c. So we need to determine our theta. Going back to our equation, from our equation 1, square root of y equal to 2 sine theta. If we manipulate, we can get our sine, right? So if we over 2, this is over 2, cancel 2, our sine theta is equal to square root of y over 2. Or we can rewrite it, so arc theta is equal to arc sine or reciprocal of sine or sine raised to negative 1 square root of y over 2. So we can say our theta. If we're going to use, we still need to use here. So sine is okay here. Sine, sine. But we have a cosine theta. So we need to determine the value of our cosine theta. So we need to draw first our right triangle. So this is our theta. From our equation sine theta, if we recall, for our sine, that is so opposite over hypotenuse. So this is opposite, adjacent, and the hypotenuse. So sine square root of y is your opposite. Square root of y is your opposite. And your hypotenuse is 2. So we need to determine the adjacent. So if we're going to determine the adjacent, become, for example, with a squared plus the square root of y squared is equal to 2 squared. So we can determine our adjacent. That is, if we transpose, we cancel out 2. So a squared is equal to 4 minus y, or your adjacent is equal to square root of 4 minus y. We can rewrite it here. So finally, our adjacent here is 4 minus y. Okay, so we have the hypotenuse 2, opposite of the square root of y, and adjacent of square root of 4 minus y. We need to determine our cosine. So SOHCAHTOA, ka, for our cosine, adjacent over the hypotenuse. So cosine theta is adjacent, or the adjacent is square root of 4 minus y over the hypotenuse 2. Okay, we have the value of our cosine theta. We have the value of our theta. We can substitute the theta here and sine theta here and our cosine theta. Okay, we rewrite our final answer. Okay, so for what is the value of our theta? That is sine negative 1 square root of y over 2. So minus 4. What is the value of our sine? That is here. We can use that. 4 quantity square root of y over 2. And your cosine theta. What is the value of your cosine theta? That is square root of 4 minus y over 2. Oh, you have a constant c. Okay, we furtherly simplify. Can we cancel something here? Okay, none. At the other side, they have a common of 2. 4, 1, 2. Okay, it's all gone. So we rewrite our final answer. So 4 sine negative 1 square root of y over 2 plus square root of y square root of 4 minus y plus c. Can we rewrite this further? Yes, we can distribute this y inside the radicand, so it will become only one radicand. Okay, so 4, again, sine raised to negative 1 can be written as your arc sine, or 1 over sine. Arc sine square root of y over 2 plus, we let the y inside they have a common of radical. So common radical y, of course, quantity of your 4 and minus y plus c. Okay, so finally, this is your final answer for your example number 28. For comment, your comment down below, or you can send it to our GC, or you can personally message me to your Moodle account. So moving on to our next example. Okay, for your next example, example number 29, can be found in your workbook on page 104. Example 29. Evaluate the integral of e raised to square root of x dx. Again, we need to evaluate our function. In this case, we evaluate e raised to square root of x. So, let's assume a certain variable. We let e raised to square root of x equal to z. Okay. So we need to solve for x with respect to your z. So we need to simplify this equation further. So e is square root of x is equal to z. If we multiply ln both sides, so we cancel out ln e, and the remaining is square root of x ln z. Then we remove the radical, so that is equal to x is equal to ln squared z. So from the radical, so we transpose it to the other side, is ln squared z. Now we need to find the first derivative of your ln squared z. So if we get the derivative of your x, that is equal to 2 ln z. Of course, your dz over z, or you can say 2 ln z 1 over z dz, or you can write it to dz over z. So we have our dx already. We have the value of our square root of x. So we can replace our existing function with our derived new variable. So solution is equal to integral of e raised to x dx. Okay, integral of, so we replace our e raised to square root of x with our new variable z. Okay, so what's next? Dx. So what is your dx? That is 2 ln z dz over z. Okay. Next step, we cancel out common. We cancel out common and we carry out real number constant outside the integrand, applying our property number 2. We're writing our function that would be 2 integral of ln z dz. So can we integrate this right away? Yes, using your IBP or your integration by parts. Again, if you're using your IBP integration by parts formula, you need to determine the value of your u and your dv. Again, we choose our ln z as our u and our dv as your z. Okay, so we apply. So if we recall our IBP formula, integration by parts, that is u dv is equal to u v minus integral of v du. Okay, so what is our u? That is ln c. If we get the derivative of our u, that is your du. The first derivative of your ln z, that would be dz ln z. The other side, your dv is equal to your dz. If you integrate, you'll get v is equal to z. Okay, you rewrite your function according to IBP format, integration by parts format, this formula. Okay, we apply. So, equal to 2. Of course, 2 is our constant. So, bracket. So, what is your u? That is your ln z. What is your v? That is your z. Minus integral. What is your v? That is your z again. And what is your dz? That is your du. dz. du. That is dz over z. Okay. So we cancel out some common term. So z. So the remaining is integral of dz. Okay, so we distribute 2 inside the bracket. So that is 2 z ln z. Z ln z minus here the integral of dz, that is z. So we carry out 2, we distribute, that is 2. The remaining is z. And your plus c. Of course, don't forget to recall the value of your z, which is equal to a square root of x. Okay? So if you're going to rewrite your final answer, okay, so we rewrite 2 a square root of x ln your z ln z, that is e square root of x minus 2 e square root of x plus c. Oops, we can cancel this out. Ln e. So finally, we can write our final answer to e raised to square root of x. So we cancel out ln e. So that is square root of x minus 2e raised to square root of x plus c. So that is your final answer for your example number 29. Okay, for comment down below the video, send your message to our group chat, or you can personally message me in our Moodle. Okay, so for our next topic, we'll be discussing about integration of rational function by partial fraction. So that is our next video discussion. So see you next time. Hopefully everyone can comprehend with our solution. If you have some clarification, don't hesitate to send your message to our GC or send your PM to your Moodle account. Okay? So that was nostalgic. So problem is kinda heavy, but just be vigilant in solving this type of problem. Don't forget your trigonometric identity. If you're having difficulties in dealing with identities, you can recall your previous subject in trigonometry to recall this identity and for you to be familiar again. And try to use them in your activity when you're solving your function. Try to use them, exploit that identity so you can explore and gather and discover new technique in solving this trigonometric function through substitution. It's either algebraic or in a trigonometric substitution. So that's all for today. Thank you everyone and have a nice day.